Now in this lecture we find out the area of a rectangle. In the drawing we have a quarter circle that is inscribed by square ABCD. We know that AEFT is a rectangle, EBCF is also a rectangle, and our mission is to find out the area of this rectangle EBCF. In addition, we know that side AE is equal to 5 units in its length. Those two blue shapes, they are equal to each other and their sizes. That is to say, the size of shape AEH is equal to the size of this shape edge FC. Again, our mission is to find out the area of this rectangle EBCF. So first of all, we define the radius of this quarter circle as R. D is the center of the quarter circle, and therefore AD is the radius, is equal to R units in its length according to our definition. Likewise, DC is also the radius of this quarter circle, that is equal to R units in its length according to our definition. In the next step, we'll define the area of the green shape. We'll define the area of this green shape SA. That is to say, the area of the green shape is equal to A square units in its size. So we define the area of this green shape SA. And those two blue shapes, they are equal to each other in their sizes. So if we define the size of this blue shape edge FC as S, then the size of this other blue shape edge FA must be also equal to A units in its length, because they are equal, must be also equal to S units, X square units in its length, because of the fact that they are equal to each other and their sizes. Again, those two blue shapes, they are equal to each other in their sizes. So if the size of this shape is S, then the size of this shape edge EA must be also equal to S square units in its size. Okay. So what is the area of this rectangle EBFC? From the drawing, it is very easy to see that the area of this rectangle EBFC is equal to the area of square ABCD minus the area of this rectangle AEDF. And again, the area of this rectangle EBFC, it must be equal to the area of square ABCD, the big square ABCD, minus the area of this rectangle AEDF. Repeat again, the area that we're looking for, that is the area of rectangle EBFC, it is equal to the area of the big square ABCD minus the area of rectangle AEDF. So what is the area of square ABCD? The area of any square is equals to the side of this square squared. So, and we know that one side of this square ABCD is R, therefore it must be equal to R squared. So the area of square ABCD is equal to R squared. In the next step we have to find out the area of this rectangle AEFD, and we subtract the area of rectangle AEDF from the area of the big square ABCD, and the result will be the area of this rectangle EBFC, that is the area that we are looking for in this question. So what is the area of this rectangle AEDF? The area of rectangle AEDF we know that the area of any rectangle is equal to the length of the rectangle times the width. The length of rectangle ABCD is R, and the width, according to what is given in the question, the width of this rectangle AEFE is equal to pi units in its length. So in total we have found out that the area of rectangle AEDF is equal to R times pi, or pi R square units. From one side, but from the other side, the area of the same rectangle AEDF, the area of the same rectangle AEDF must be equal to the area of the green shape, that is equal to A square units according to our definition, plus the area of this blue shape that equals to S square units according to our definition also. So from the other side we found out that the area of this rectangle AEFD is equal to A plus S square units. So we have here two equations for the area of this same rectangle AEFD. According to equation 1, the area of rectangle AEDF, we already found out that according to equation 1, the area of rectangle AEDF is equal to pi times R square units. So we have two different equations from the area of rectangle AEDF. Therefore, we create equation 3 that states that the area of rectangle AEDF, according to equation 1, must be equal to the area of the same rectangle AEDF according to equation 2. The area of rectangle AEDF according to equation 1 is equal to pi R, and it must be equal to the area of rectangle ABCD according to equation 2, that is equal to A plus S square units. Okay. What is the area of the quarter circle? What is the area of the quarter circle? Actually, we know that the area of any quarter circle is equal to the area of the circle over 4. That is to say, it is pi r squared over 4 from one side, but from the other side, the area of this quarter circle equals to the area of the green shape plus the area of the blue shape. The area of the green shape is equal to A square units plus the area of the blue shape, that is equals to S square units according to our definition. So in total, we found out that from the other side, the area of the quarter circle is equal to A plus S. So in the next step, we create equation 5 that says that A plus S, according to equation 3, must be equal to A plus S according to equation 4. Okay, A plus S according to equation 3 must be equal to A plus S according to equation 4. So A plus S according to equation 3 is equal to pi r, and it must be equal to A plus S according to equation 4, that is equal to pi r squared over 4. Again, according to equation 1, according to equation 5, A plus S according to equation 3 must be equal to A plus S according to equation 4. A plus S according to equation 3 is pi r, and it must be equal to A plus S according to equation 4. A plus S according to equation 4 is pi r squared over 4. So in total, according to equation 5, we have to find out that pi r equals to pi r squared over 4. Here we multiply this equation by 4 and we get that 4 pi r is equal to pi r squared. 4 pi r equals to pi r squared. Here we will divide this equation by pi r and we get that 4 pi r over pi r is 4, and it is equal to pi r squared over pi r. Pi r squared over pi r is of course r. So in total, if we found out that the radius of the semicircle is equal to 4 units in its length. The radius of this semicircle and this quarter circle is equal to 4 units in its length. AD equals to DC equals to the radius of the quarter circle, that is 4 units. Okay, so now we can easily find out the area of rectangle AEFD. The area of this rectangle AEFD, it is equal to the width times the length, that is actually pi r. So write it down, the area of this rectangle AEFD the area of rectangle AEFD is equal to the length, the width for the rectangle, that is pi, according to what is given in the question, times the length, that is r. So in total, it is pi r. The area of rectangle AEFD is equal to pi r square units. But we already found out that the radius r is equal to 4. Therefore, pi r is 4 pi. So in total, we found out that the area of the AEFD is equal to 4 pi square units. Our mission is to find out the area of this rectangle EBFC. And we already found out in the beginning of the lecture that the area of this rectangle EBFC it must be equal to the area of the big square ABCD minus the area of this rectangle AEDF. So repeat again, the area that we're looking for, that is the area of this rectangle EBFC, it is equal to the area of the big square ABCD minus the area of this rectangle AEDF. The area that we're looking for in this question, it is the area of rectangle EBFC, it is equal to the area of the big square ABCD minus the area of rectangle AEDF. The area of square ABCD is equal to R squared minus the area of this rectangle AEFD. We already found out that the area of rectangle AEFD is equal to 4 pi. So in total we found out that the area of rectangle EBFC, that is the area that we are looking for in this question, it is equal to R squared minus 4 pi. R equals to 4 units in its length, therefore R squared is 4 squared, that is 16 minus 4 pi. So in total we found out that the area that we are looking for in this question, that is the area of this rectangle the area of this rectangle EBFC is equal to 16 minus 4 pi. In terms of numbers, 16 minus 4 pi is equal to 3.43 square units. That is the answer to the question. I repeat again, the area of this rectangle EBCF is equal to either 16 minus 4 pi square units, so in terms of numbers, the area of this small rectangle EBCF is equal to 3.43 square units. So in the next step, I'll start the lecture. In this lecture, our mission is to find out the area of this rectangle, small rectangle EBCF. It is given us the question that we have here this quarter circle that is inscribed by this square ABCD. We know that AEFC is a rectangle and EBFC is also a rectangle, and our mission is to find out the area of this small rectangle EBFC. What is the area of this small rectangle EBFC? It is equal to the area of the big square ABCD minus the area of this rectangle AEFC. Again, the area of square ABCD minus the area of this rectangle AEFC, it is equal to the area of this small rectangle EBCF. And again, the area that we are looking for in this question, that is the area of the small rectangle EBFC, it is equal to the area of the big square ABCD minus the area of rectangle AEFC, AEFD. Okay. Again, the area of this small rectangle EBFC, it is equal to the area of the big square ABCD minus the area of this rectangle AEFD. Okay, first of all, we define the radius of this semicircle as R. So AD equals to R, BC also equals to R. We define the green area as A. That is to say, the green area equals to A square units in its size according to our definition. It is given as the question that those two blue shapes, they are equal to each other in their sizes. So if we define the size of this shape, this blue shape as S, then the size of this blue shape must be also equal to S because they are equal to each other in their sizes. So the area of the big square ABCD must be equal to R times R, that is R squared. In the next step we have to find out the area of this rectangle AEFD. Actually we know that the area of a rectangle equals to the length of the rectangle times the width. Therefore the area of this rectangle AEFD must be equal to the length that is R times the width that is pi, according to what is given in the question. So in total, the area of this rectangle AEFD must be equal to pi times R squared. So for one side, the area of rectangle AEDF, it is equal to pi R square units, but from the other side, you can find out the area of this rectangle AEFD in another way. Actually, the area of rectangle ABCD must be equal to the area of the two components that it consists of. It consists of the blue shape, that is the first component, and it consists of also this green shape, that's actually equals to A square root in its length. The blue shape is equals to S square root in its size. Again, the area of the green shape is equals to A square root in its size. So in total, the area of rectangle AEFD must be equal to A plus S square root. So from the other side, the area of rectangle AEDF must be equal to A plus S square root according to equation 2, while according to equation 1 we only found out that the area of the same rectangle AEDF is equal to pi r square roots. In the next step we created equation 3 that says that the area of rectangle AEDF according to equation 1 must be equal to the area of rectangle AEDF according to equation 2. The area of rectangle AEDF according to equation 1 is equal to pi r and must be equal to the area of rectangle AEDF according to equation 2, that is A plus S. So in total we found out that according to equation 3, pi r equals to A plus S. What is the area of the quarter circle? Actually we know that, what is the area of this quarter circle? We know that the area of any quarter circle equals to the area of the circle over 4. That is to say it is pi r squared, that is the area of the circle over 4. Therefore, the area of this quarter circle must be equal to pi r squared over 4 from one side, but from the other side, the area of the quarter circle must be equal to the sum of the areas of the two components that it consists of. The quarter circle consists of two components. The first component is this green shape, and the second component is this blue shape. So the sum of the areas of those two components, it is actually A plus S. So from the other side, the area of the quarter circle must be equal to A plus S. So in the next step, we created equation 5 that says that A plus S according to equation 3 must be equal to A plus S according to equation 4. Again, A plus S according to equation 3 must be equal to A plus S according to equation 4. A plus S according to equation 3 it is equal to pi r. And it must be equal also to A plus S according to equation 4. A plus S according to equation 4 is equal to pi r squared over 4. Pi r squared over 4. In total, according to equation 5, we actually found out that pi r equals to pi r squared over 4. Here we multiply this equation 5 by 4, and finally found out that 4 pi r equals to pi r squared. Here we divided this equation 5 by pi r, and we actually found out that 4 pi r over pi r is 4, and pi r squared over pi r is r. So in total we actually found out that the radius of this quarter circle r equals to 4 units. Now it is very easy to find out the area of this rectangle AEFD, because it is equal to pi r, and r is 4. Therefore, it must be equal to 4 pi. Okay, again, the area of this rectangle AEFD must be equal to the width of the rectangle times the length. The width is pi according to what is given as the question. The length is r, that is 4. Therefore, in total it is 4r. It is 4 pi, or it is pi r, and r is 4. Therefore, in total it is 4 pi square roots. So again, the area of this rectangle AEFD, this equals to pi r. The area of rectangle AEFD, it is equals to pi r, and r is 4. Therefore, it is 4 pi. The area of this rectangle AEFD is equal to 4 pi square roots. Our mission is to find out the area of this small rectangle EBFC. The area of this small rectangle EBFC is equal to the area of the big square ABCD minus the area of this rectangle AEFD. Repeat again, the area of the small rectangle EBFC is equal to the area of the big square ABCD minus the area of rectangle AEDF. The area of the big square ABCD is equal to r squared minus the area of this rectangle AEDF, that is equal to 4 pi. So in total, the area that we are looking for this version that is there of the small rectangle EBFC must be equal to r squared minus 4 pi. R is 4, therefore r squared is 4 squared, that is 16, minus 4 pi. So in total, if you found out that the area of this small rectangle EBFC is equal to either 16 minus 4 pi square units, so in terms of numbers, the area of this small rectangle EBFC it is equal to 3.43 square units. Okay, thank you very much.